Hello there. I'd like to welcome you to the Chapter 11 Study Guide session in Docere, also called the Chapter 11 Review. So this is a glacial chapter, or glaciers. So 15 questions. Here we go. Question number 1. A glacier is what? Letter A, is a glacier ice? Letter B, is a glacier frozen fresh water? Letter C, is a glacier moving under gravity or under the influence of gravity? Or is letter C, is a glacier all of the above? So the answer is all of the above. A glacier is ice, and it actually is frozen fresh water that moves downhill under the influence of gravity. So question number 2, this is the extent of the last ice age, or the last ice that ever covered North America. And there was also a big chunk of it over here in Greenland. That is ice. So your job is to answer this question. What type of glacier is that? And there were 2. Okay, this is a continental glacier, or also called an ice sheet. So in this map of North America, this is the approximate location of many of today's glaciers. So what type of glacier are they? These are called what glaciers? Okay, they're valley glaciers, but it also goes by a different name that starts with the letter A. Okay, these are alpine glaciers. Question number 3, this is a review from a previous chapter. This is a pie chart is representing all the world's water. And what percentage of this pie diagram is fresh water? Okay, that's 3% right there. And inside that 3%, which is fresh water, how much of that 3% is actually trapped in the world's glaciers? That is 2%. Question number 4, I have a U on the left and a V on the right. Which one is actually a glaciated valley? Is a glacier indicated by a U shape or a V shape? And that is a U. Question number 5, where are 2 major ice sheets that you can find in the world? Where are you going to find 2 major ice sheets? Well, the first one is up here in Greenland. And the second, of course, is Antarctica. So if we examine these 2 ice sheets a little bit more closely, if these were to melt completely, which scientists say they think it's impossible, or unlikely, I should say, sea levels, they claim, would rise how much feet, or how many feet? That's 230 feet, so that is a lot. Question number 6, this is kind of a cheesy little diagram here. Things that are merging into other things will eventually form a big block of ice. So I have 4 choices here of one thing that merges into another. So the first picture is things that fall in the wintertime. Okay, that's snow. So snow will compact to form what? This is granular snow. Granular snow compacts to form firn. And then firn finally compacts to form glacial ice. Question number 7, we have a picture from your textbook, I believe. And I've labeled some zones inside of it, Zone A and Zone B. So between A and B, which is the brittle zone? A or B? Okay, that's A. And of course, which one is a plastic zone? That is labeled B. So between A and B, where are you likely to form or have crevasses? And that is in Zone A at the top. So this is my feeble attempt of drawing an alpine glacier from a helicopter. So I have a red circle, a purple square, and a green triangle to help us out. So which zone is the zone of accumulation, where new snow falls? This is where the red circle is. Which one is the zone of wastage, also known as the zone of ablation? That is the purple square. And the calving face, where are you going to find that? That is down there at the green triangle. And that's question number 8. Same picture, but different concepts. So I have some huge rocks that are being dragged along by the base or bottom of the glacier, and they're being dragged along that bedrock surface. So what is the name of the process where big rocks are dragged along and they're actually taken out of the bedrock? Okay, this is plucking, glacial plucking. And because you're basically grinding these big boulders down across the face of the bedrock, it leaves beautiful parallel grooves, which are called, these are called striations or glacial striations. Question number 10, I'm over halfway done now. Your job in question number 10 is to name some glacial erosional features. Glacial erosional features. So I have 4 blanks, so good luck. No, I'm kidding. I'm going to help you out a little bit. The first one starts with an H. It represents the top of the mountain peak. This is a horn. The next one is a spoon shape or amphitheater shaped structure, which is called a cirque. Okay, the very sharp ridge along which people could potentially walk is called an arête with a little cute little hat over the first E. And if a cirque gets filled with water, that's called a tarn. So the complement for that question number 10 is question number 11. Now your job is to name some depositional features found in glaciated terrains. So only 3 blanks on this one with only a few letters to help you out. So all the junk that a glacier pushes along is known as, it starts with a T. This is till. The till could be mounded up in a beautiful, pretty way to form moraines. And then something that looks like a snake is called an eskier. Question number 12, a picture for your consideration. I want to know the name of that big crack. That is indeed a crevasse. And where is that crevasse found? What zone? Okay, this is a brittle zone at the top of the glacier. Question number 13, we're now again looking at an alpine glacier from an aircraft or in a helicopter. So we have layers A, B, and C, and all that gray stuff is basically dirt that the alpine glacier is pulling down. So which one represents a lateral moraine? A, B, or C? Okay, that is A. Which one is a medial moraine? That is B, because it's where 2 glaciers basically merge. And which one, of course, is the end or terminal moraine? And that is C. Okay, 14, you're bebopping along and you're minding your own business and you find a big boulder in the middle of a flat field. And what might you call that big boulder in the middle of the flat field? Okay, that geologically that's called an erratic. But there's a problem with erratics. Erratics have to be found, at least glacial erratics, have to be found within the glacial limit. So where are you likely to find erratics in the United States? Here in Florida? Here in Minnesota, Michigan? Or here next to Las Vegas? Okay, you're likely to find them up north, and the reason why is because the dotted line represents the extent of the last ice age that went down to southern Illinois, Indiana. So this last ice sheet covered North America during what period of geologic time? Okay, that is called the Pleistocene. Okay, here is our final question here, number 15. This one is clearly labeled for you. This is the ellipticability, or eccentricity as we call it in class. Okay, this one is a tilt, which starts with an O. And this one is a wobble, which starts with a P. So can you name the tilt of the Earth? What's the O word? Okay, that's obliquity. And the P word to describe the wobble that the Earth makes on its axis is precession. And obliquity, precession, and eccentricity are all parts of what big cycle? And even though I didn't spell it, it's called the Milankovitch cycle. Okay, so this now concludes our Chapter 11 study guide session.